This time on Captain Castle's Laboratory, we're working on a Department 56 Up, Up, and Away Christmas piece. There is no box, it's just this, which, let's see, came from 1998. March of 1998. Now, I got several of these sent to me that don't work, and all of them, they're blown out right here in the center. I think it's because the wires for the motor go underneath it, and this gets brittle. But I have multiple, like all at once, everybody is sending me the exact same piece, which is totally fine. Just do them all at the same time. So I'm going to film one so you can see how to fix it yourself. Now this piece has a reindeer that hangs right here on the hook, and a reindeer and the sleigh, and it spins around in a circle. That's all it's supposed to do. So if I turn it on, it goes and then it stops. And yeah. So anyway, the motor's broke. So, and I know it's the motors, the style that they used to use back then. First thing is unplug it from the wall, because this is a 120 volt piece. Which is why on the bottom it says caution, this is not a toy, and of course in big, bold, tall caps it says risk of electric shock. So anyhow, and apparently it's old. So this needs a motor. The motor in here is a synchronous motor. And Happy Holidays with an S, Parts with an S, does sell the replacement kit. And it is a kit to replace this. So the first thing to do is remove the bottom. Try whatever you need to do it. I usually cut around the edge because if you heat this, it just melts. I've done this many a times. Something like this, if you really wanted to, you could just cut the center out since it's already ripped open. There's multiple choices, but on these older pieces that have this plastic sheet, the glue they use has a higher melting point than this plastic sheet. That's the problem. So I usually just try and see the cord is right here. So I need it to fold this way. So I'll take a razor knife or an X-Acto knife. Make sure you don't stab yourself. Now, if you're one of those lucky ones where the bottom is starting to peel off, you might be able to. I've only ever had one that was sent to me that the bottom, the glue had started separating, and I was able to peel most of the bottom off. Now, if you do cut it, be careful, because once you get to here, you need to make sure you're at a very shallow angle so you don't cut through the power wires. That's one of the reasons you want to make sure it's unplugged. They use this non-removable base is because it's 120 volts. So it's mains power, which means that you have a really good chance of getting electrocuted or get a bad electric shock. It's just got two wire nuts, which I'm just going to slice the heat shrink off of so we can unscrew it. So I just slice it off of the wire nut. That way I can unscrew the wire nut. And usually I can just pull it out from underneath the heat shrink, but apparently I didn't cut all the way through. Sorry if it seems a little fidgety. I got stung by a scorpion in my thumb, so my thumb doesn't work like it used to at the moment. It's a little swollen and hurts like a sumbitch, but that's just what scorpions do. There we go. Now it's cut all the way through. I can just unscrew the wire nut. But just because a scorpion tags you doesn't mean life comes to an end. You still gotta get stuff done, and you just got to do it a little differently. Apparently, unlike other ones, these wire nuts don't want to come off on camera. So I've done this 100 times and never had a set of wire nuts just stay stuck. There we go. There's one. Then you can slide the heat shrink up and off the wire. Now on some of the skating rinks, they did put hot glue inside the wire nuts, which makes it more difficult, but on these they don't. They're just heat shrunk on. There we go. So now we can take the wires off. Now we have to remove this center plate, which is held on with 5 screws. There is an intentional missing screw here because there's no boss, so there's nothing for the screw to screw into. They are number 2 screws, so I'm just going to use a drill with the number 2 bit. That was the razor knife rolling off the table. And then we're going to move the top out of the way so we have access to this. Now, this should not come out. When they slip like that, it's because this has broke free. You can see the nasty grease. It's not clear anymore. And the piece inside that's supposed to retain this is loose. Very common on these motors to have this piece. If it pulls out, it's bad. So let's throw that away. And let's get this off the floor. Now, on the originals, they're riveted in. So if you haven't seen any other videos that I've done, you have to drill out the rivets. So get a sharp drill bit. That way you don't heat the plastic up too much. And drill out the rivets. You can drill them out from the back or the front. Let's do this one on the back so it's on a flat surface just to relieve the stress off my thumb. Alright, well that is spinning. So let's go to this one. Let's see if this one... Alright, so both of these are spinning, and that can be a problem. Meaning that when the rivet isn't tight enough and it's spinning with the drill bit. If that's the case, you need to wedge it. There's a couple ways of doing it. Let me try it this way first. So I'm going to put the pliers on the tip of the pliers on the inside and try and squeeze it against the plastic housing and see if I can get enough bite to where I can get this to not spin so I can drill out the front. So no, I don't have enough grip with those. Try the bigger ones. Bigger ones are going to be too big. Let's try this hole. Too big. Medium size. Still too big. Alright, so I'm going to do what they tell you not to do. I'm going to try and hold it with my finger. Moved. Let's see if I can do this one now. The reason you're not supposed to hold your finger is you can cut yourself or get hot and burn yourself. Or if you punch through, you can slam the drill bit into your finger. My left hand's already sore enough. A little bit more isn't going to hurt it any. Because it's the rivet's still going through the plastic, I just use a small blade screwdriver and carefully try and pry it up, just walking it so it pops free. Luckily with this style versus the ice skating rinks, this has a reinforcement ridge around it, which helps keep the motor aligned, and that allows you to pry carefully, of course, doing minimal damage. So there's your bad motor. Now, I just look for any burrs, because sometimes when that rivet spins, you'll get a burr. If you get a burr, just take your knife and trim it off. That way the motor sits flush, and the kit with its new parts will work. So here's the kit. And I'll link below where to get the kit, and it's not a cheap kit. Just so you know, this kit right here is basically 60 bucks. I think it's like 55, and you might pay shipping depending on your order amount or tax, depending on your state. So it comes with a motor. And a new, so let me grab the old motor. Here's the old motor. And the old extension shaft. So this is what your original one was. Of course, it's not going to go back in the hole because it's shifted. So how this one works is this is your replacement. So this is a 3D printed block from Happy Holiday Parts, which is probably why it's an expensive kit, with Allens on both sides. That's why you have an Allen wrench. And I'll show you how this works. It's actually pretty ingenious, because trying to fabricable something like this is probably a little bit more difficult. And because this just uses basically the type of plastic / rubber this is, it just uses compression to hold the shaft. So if this wears out, that shaft can spin freely inside, meaning there's no more grip on the inside of this piece here. Don't need that anymore. So this comes with 2 flat Phillips screws and 2 self-locking washers. Now the motor can only be put on one way. You can see by the shape and the shape of the wings. They're not directly across from each other. So the motor just pops on. There are 2 plastic standoffs for alignment. So just there and there. So now the motor's in on the standoffs. And of course, I'll try and hold it with my thumb. Just take the screw and you stick it from the inside. That's how I do it. You don't have to, but it fits better than going against the casing of the motor, because the top of the screw is fat. And the nut. It's a fidgety process. Always the part I always have issues with. The new hardware is non-magnetic, so it makes it a little bit more difficult. So it's not like I can just stick it on the screw gun and then do its thing. So I screw that one in until it reaches the nylon. Once it hits the nylon, you need to put a tool on it. But that holds it so I can get this one in. So it's not tight, so you need to put a tool on it. Now you can try and find an itty bitty little wrench that fits that. That's up to you. I don't. I use a pair of needle-nose pliers or something. Now on these wire cutters, the jaw, which says pliers, has teeth. So that allows me to grab it and hold it. So You don't have to use an electric screwdriver. You can do this with a handheld. And now it's nice and tight. So how this works. First thing, comes with this little lock washer. We slide it over the threaded shaft. Then we take that and we thread this in. Once it bottoms out, carefully turn it with your fingers until it's tight. And I'm doing it very slowly because if you real hard, you can snap the gears inside the motor. Because the only thing stopping this is those gears, because they're not designed to spin backwards. And that's it. And you're saying, oh, what's the Allen wrench and stuff? So you need to have your hoop, your hook, whatever you want to call it. And we're going to drop it in. And now we're going to adjust it. Not smack myself in the face. We're going to adjust the tension on this. So this one's backed out really far, so we're going to put it in. It's just now touching the hoop. So now, or the hook. The bottom of the hook, if you've never seen one, is not round. It's got 4 flat sides. It's wedged or compressed or whatever you want to refer to it as. So we want to make sure that we can get this to drop in, but it's not so tight that there's a problem. So that's what these are for. It's to adjust the tension on the bottom. If you torque this, you'll never get the hook out to put the bottom on. So I usually go up until it hits, and then I back it off about a quarter. Go up until it hits, can't pull it out, and then back it off about a quarter. And now I have a nice snug fit that it doesn't spin inside of there. Now, if you are concerned about these backing out, if you look inside here, you can see there's 2 nuts that those Allens thread into. You can take a drop of super glue, you can take a drop of Loctite. I would recommend clear nail polish and putting a drop on so it runs down inside the outer edge between the nut and the thread, so this side. Clear nail polish allows it to, when it dries, it cures and prevents it from backing out. It's like Loctite, but a little, and it'll crack free and you can unscrew it. Clear nail polish is really good for holding metal on metal parts as a semi-permanent thing. So you do have options if you're concerned about them backing out, because there is no massive amounts of tension. But at the same time, there's really no reason these should unscrew themselves. So, and you get a free Allen wrench with purchase, apparently, because each one comes with it. So now we want to bring back this piece. Now, if you want to cut the whole bottom off to make it easier for you, more power to you, you can do that. I don't. That way I have the alignment for running a glue bead on the inside edge and smushing it back on. And now I do use hot glue versus super glue, because at some point this motor is going to die again. It's just life. Nothing lasts forever. Now we just make sure all our tabs are lined up, like so. So it drops in. It's got 1, 2, 3, 4 alignment pins. And if you don't think it's lined up, like you think you're 180 out because it's an offset motor, go ahead and take your hook, find the hole in the plastic base, and make sure it drops in, which is right there. And then the hook doesn't move because it's inside the teeth. That's if you're concerned. I mean, you shouldn't have that problem because it's a keyed setup. But if you just want to double check your work because you haven't done it before. Just get 1 screw in there to hold it while I get the rest of the screws to put it back together. Now you can use a drill or a screw gun to tighten them, but you got to have trigger control, because if you have too much pressure, you'll snap the plastic. So if you don't want to do it this way, you can just grab yourself a Phillips and tighten them by hand the rest of the way. So whatever is easiest for you, you need to have trigger control. That little handheld screwdriver here only has a number 1.5, so it won't tighten these, it'll just skip. So I just put them in to where they hit to make sure that it's seated before I pull out a screw gun or a screwdriver. Now, this is an AC unit, so the wires don't matter which one goes where. Make sure you don't have any frays hanging down, because the wires are stranded. Go ahead and twist your wires and then put the wire nut on. Like so. Now you can test it right now to make sure that it works before you finish the reassembly. I'm going to go with I have faith that this is a functional motor. So if you don't have heat shrink to reheat shrink the tops like we cut off, you can use hot glue, because like I was saying, some of their pieces have hot glue, especially their skating rinks, or if you can use electrical tape if you want. But you definitely want to put something on here so that the wire nuts don't come off from expansion and contraction from thermal changes, so hot, cold, hot, cold. That's the main reason that this is on here. The second reason is in case there is a fray, hopefully the fray is contained within the heat shrink and they won't touch each other, because it becomes a very shocking experience. You can use anything you want to shrink the heat shrink. I'm just going to use a lighter for speed. It's faster than waiting for the heat pen to get warm. I'm shielding the lighter from my ceiling fan. That's why it's flopping all over the place. It's supposed to be 113 and I'm working with Christmas stuff. Just seems right. There we go. And let me go plug this thing in. Let's drop this inside. Fine work. There we go. It's latched in. Plugged in. And there you go. So, with commentary, less than 30 minutes. If I had a functional thumb, if this thumb wasn't swollen, and you can kind of see the swelling in the pad, and not as movable, it would be probably done in like 5 minutes. Very fast. Now, on the bottom, to reassemble your bottom, if you trust that nobody's ever going to touch it, you can leave it as it is. You can cut it off and throw it away. It's yours. You can do what you want. I'm all for it's yours. You own it. You have the right to do whatever you want to do with your own product. I know some companies out there don't agree with that, and that's their choice. So what I do is I take the hot glue gun and I run a bead right on the inside edge here, and I mush it on, and then I try and smooth it out over the top. Some people say that's wrong or whatever. There is no right way, because there is no way to repair these according to Department 56. And that's why their newer pieces are slightly easier and different, is because they are repairable, kind of, compared to these older pieces, which they just wanted you to throw them away because of the electric shock hazard, because these all ran on main voltage. So how you assemble yours is your choice. Another option you can do is, if you want to cut the entire thing out, leaving yourself maybe a 1/4 inch to a 1/2 inch or even an inch of inner, you can go get felt from like Michael's or Joann's, possibly in white since this is Christmassy, and just glue it on, stick it down, and once it cures, take a razor knife, cut around the edge to the footprint, and then you have a felt bottom. I've done that with Limex, and I've done that with some Department 56, but mostly Limex because they come with a foam rubber pad on the bottom. So, but just to give you some choices. The stick-on stuff that's self-adhesive, you can use that too. It would only stick around the edges and the corset where the motor is, and then you'll just have dead spots in the rest, which doesn't matter. If you do stick it on, I wouldn't recommend hot glue. I would recommend the spray adhesive like Gorilla or 3M. That way you get more of an even coat. And if you do a single pass, you could peel it off in the future. If you do a double pass, you'd have to cut it off. But when this stuff soaks in the felt, the hot glue, it makes it lumpy, chunky, and kind of hard to deal with, and it looks like crap. At least that's my experience with it. You may have varying experiences, of course. And as far as the spray adhesive, it works really good on fabric, especially if you buy fabric spray adhesive. I personally use Gorilla and 3M. I use 3M 75 or 3M 90, and I also use just regular old Gorilla Glue adhesive. I found those work the best for me. And that's an option. Now, if this was my piece, which it's not, because I, 1, don't do Christmas, and 2, I don't do Christmas, but if it was my piece, I probably would leave the bottom off of it, because my stuff usually stays up all year round, and normally I don't let anybody touch it. That's just me. But personal preference, personal choice. It's your options. So hopefully this helps if you have the up and away from Department 56 and you need a motor, because there's no other mechanism inside. Like I said, they come in this handy little kit. You can see I have more because this is only number 2 of several. They are very expensive kits, but your choice is try and find a used one that maybe works, or throw it away. If it's something you like, since they don't make it anymore, since it's 26 years old, it's well worth investing the $60 into it and 20 minutes of your time. So, well, until the next one, thanks for watching. Any questions or comments, leave them below. Have a good one.